Hello and welcome to my science tutorial. In today's video we are going to be looking at binomial expansion using the Pascal's triangle. So before we start, let's know what a binomial is. So binomial or a binomial is any expression containing two terms connected by an addition or a subtraction sign. So you can have a plus b, okay, with a certain power, let's say 7, can be said to be a binomial. Okay, then we can have maybe c plus d, but it's also a binomial. So this can be said to be binomials. Now, expanding these terms using multiplication can be very difficult at times and times consuming. So to actually facilitate the expanding of these questions, we tend to use the binomial theorem or the Pascal's triangle. Now in this video we are going to focus on the Pascal's triangle. Okay, so what do I mean by this is difficult? Assuming we have this example over here and we are to expand, come on, tell me, can you just keep multiplying a plus b, then times a plus b till 7 times? It's very tedious, it's exhausting. After expanding this, you feel like you've done a great job, but then by the time you realize your colleagues are somewhere else. So we need to find an alternative means of expanding this very easily, and that is what the Pascal's triangle and then the binomial theorem wants to help us achieve. So let's have a look at what the Pascal triangle is. Now the Pascal's triangle gives the coefficient in the binomial expansion to form a useful pattern. So the Pascal's triangle, it gives us the coefficient. So once we know the coefficient, we can continue with the expansion. What do I mean by this? Let's have the binomial here. So binomial, we have here the binomial. So we have the coefficient that we are going to get after using the Pascal's triangle, and then the expansion. So using the coefficient, we can get the expansion of the form that we want. So let's have the binomial a plus x raised to the power 0. Now any number raised to the power 0 is 1, so we know. So the expansion will also be 1. Okay, the whole of this all will be 0, will be 1, sorry. Now if we have a plus x raised to the power 1, okay, this is just like a plus x, so the coefficient of this and this are 1 1, so we still have what, 1a plus what, 1x. Now from the second one it becomes interesting, which is the third over here, the second power. So we have a plus x raised to the power 2. So for this expansion we tend to repeat, we have 1 over here, okay, so we have 1 over here, so we repeat the 1. Now 1 plus 1, we add this 2 and write it at the middle, so it will give us 2. Then we repeat this one at the end again. So what this is telling us is that first we need to write 1, then the a term, then we square it, then plus, then we write 2 as the coefficient. Now this the power of the a squared terms will decrease, so we have a, then we introduce the x, then plus 1. Now the a has decreased from 2 to 1, so it will now go to 0, which is still a power 0 is still 1, so we ignore that, and then we write the x. Now the x, the power here was 1, so it will increase to 0, it will increase to 2, sorry. So we assume over here the x over here has the power of 0, so it is 1. So this is the expansion that we will get. If we have a plus x raised to the power 3, we repeat the 1 over here. 1 plus 2 give us 3. Now 2 plus 1 will also give us 3. Now we repeat the 1 again. So it means the expansion we'll be getting is what? 1a power cube plus 3a. Now the power will decrease 2. Then we have x plus another 3a. The power will decrease from 2 to 1. Then at the x, the power will increase. Then plus 1 x raised to the power 3. Okay, so if we have a plus x raised to the power 4, it will continue with the same trend. Okay, so we will have 1, then 1 plus 4 will give 1 plus 3 will give us 4, 3 plus 3 will give us 6, 3 plus 1 will give us 4, and then we repeat the 1. So the expansion will be getting there over here. You can see the pattern that it is following. So a power 4 plus 4, the 4 over here, a power 3, then we have the x plus 6 a square s square plus 4 a s cube, then plus 1 x power 4. Okay, so if we have a plus x raised to the power 5, guess what the coefficients are going to be? So they will be 1. We repeat the 1 plus 4 is 5, then 4 plus 6, sorry, will give us 10. 6 plus 4 will give us another 10, and then 4 plus 1 will give us 5, and then we repeat the 1. So this expansion will give us what? 1a raised to the power 5 plus 5a power 4x, then plus 10a power 3s square plus another 10 again, a square s cube, then plus 5a x power 4, then plus 1 x power 5. So this is the binomial expansion using the Pascal's triangle. So the Pascal's triangle is giving us the coefficient that we need, and then this is the expansion form. Now we need to know how to derive the Pascal's triangle ourselves, okay, so that it can facilitate our work for us if we are doing it. So let's look at that. Okay, so let me get rid of this and let's solve one practical example. Sorry. Okay. Oops. Okay, so example number 1. So now we need to know that the Pascal's triangle is only useful for n values less than 8. So what do I mean by that? So we have a plus x raised to the power n as the general formula. Well, for n values less than 8, so for n less than 8, the Pascal's triangle is useful. So from power 1 to power 7, the Pascal's triangle is really useful, but then above it, the Pascal's triangle is not really useful in that sense. Then we tend to use the binomial expansion rather to do that. So let's have our first example. So we have example number 1, 2x minus 3y raised to the power 3. Okay, so from here, let's compare this to the general formula where we have a plus x raised to the power n. So we can say from here, our a is what? Our a is 2x over here, then our x over here, comparing to the general formula, our x over there is negative 3y. Mind you, the negative sign is attached to the 3, so we carry it along. Okay, and then our n is equal to what? 3. Okay, now the Pascal's triangle with the power 3, if you copied what the pattern we derived earlier, you can see it follows what? 1 3 3 1. Okay, so this will be the coefficients of the Pascal's triangle. So from here we can just go ahead straight and solve using this. So it means for the general expansion a plus x raised to the power n, what we are going to get is, for the binomial having the power 3, we will have 1a power 3 plus 3a square x, then plus another 3a s square, then plus 1s cube. So all we have to do from here straight is to put the value of a, x, and then a and x into this expansion, and then we get our answer. Cool. So we have 2x minus 3y over here cube will be equal to what? 1 into bracket, the a is 2x, so 2x cube, then plus 3 into bracket a, 2x squared, then our x is what? Negative 3y, so we have negative 3y over here, plus another 3, then our a is 2x, then our x is what? Negative 3y squared, then plus 1 into bracket negative 3y cube. Okay, so from here we can simplify. So this will give us what? 8s cube plus 2 squared times 3 will give us times negative 3 over here, don't forget this, will give us negative 36s squared. The s square is from here, then we have the y, which is from here, then plus 3 times 2 times negative 3 square will give us what? Positive 54xy square. Then plus, then we have negative 3 cube will give us negative 27, negative 27y cube. Okay, mind you, if you square and we have y attached or x attached, always remember to square it and then like have the powers over there. So our expansion for this example will be what? 8s cube minus 36s square y plus 54xy square minus 27y cube. Okay, so this is how we use Pascal's triangle to solve an example or to expand something. So yeah, let's look at another example to wrap up this tutorial. Okay, so example number 2, we have here 2x minus 3 raised to the power 4. Okay, so comparing this with the general form a plus x raised to the power n, we can see our a is what? 2x, and then our x is equal to what? Negative 3. Okay, and then our n is what? 4. Okay, so yes, then if you remember the coefficient of the Pascal's triangle with the power 4, we will be having what? 1 4 6 4 1. Okay, so once we know this is the coefficient, it means if we have the form a plus x raised to the power n, the expansion we are getting for the using the Pascal's triangle with the power 4 will be what? Here should be 4, so we'll be having what? 1a power 4 plus 4a cube x plus 6a square s square, then plus 4a s cube, then plus 1x power 4. So for this example, which is 2x minus 3 raised to the power 4, we just input the value of a and x over here and we get our answer. So we have 1 into bracket, the a is 2x, so 2x power 4 plus 4 into bracket 2s cube, the x is negative 3, then plus 6 2x squared, then negative 3 square, plus 4 into bracket 2x, then negative 3 cube, plus 1 into bracket negative 3 raised to the power 4. Okay, so if we solve this, 2 raised to the power 4 will give us 16, then the x2 raised to the power 4, then this will give us negative, so minus because of the negative sign over here. So 3 times 2 raised to the power 3 times 4 will give us negative 96 s cube plus 6 times 2 squared times negative 3 square will give us positive 216 s squared, then minus this 4 times 2 times 3 cube, okay, negative 3 cube will give us negative 216x, then plus negative 3 raised to the power 4 will give us 81. So this is our expansion using the binomial using the Pascal's triangle to solve this example. Okay, so I hope you learned something in this video, and I'll see you in the next video where we will talk about the binomial theorem and then how to use the binomial theorem expansion to solve questions having a bigger power, like from 7, 8 and above. Okay, so thanks you guys for watching. If you are new to this channel, consider subscribing and then turn on the notification button to actually be informed whenever we upload a new video. If you like the video, kindly push the like button and then comment below the topics you want us to treat in the subsequent videos. Thanks for watching, and then we'll see you in the next video. Bye bye.